Jupiter is flinging comets toward Earth. Some astronomers believe that Jupiter, instead of protecting Earth from dangerous comets and asteroids, is actively flinging objects into the inner solar system. New research now demonstrates this complex process in action. A popular theory suggests Jupiter, with its tremendous mass, acts like a gigantic shield in space, sucking in or deflecting dangerous debris left over from the formation of the solar system. That makes sense, but the Jupiter shield theory, as it's known, has been falling out of favor over the past 2 decades. A leading critic of this theory, Kevin Grazier, formerly of the West Point U.S. Military Academy and NASA, has sought to debunk this idea for years. He has published several studies on the subject, including a 2008 paper titled, "Jupiter as a Sniper Rather Than a Shield." Indeed, with each successive paper, Grazier has increasingly demonstrated the ways in which Jupiter, instead of being our protector, is actually, though indirectly, a pernicious threat. Grazier's latest foray into the subject involves a pair of companion papers, one published in the Astronomical Journal in 2018 and the other in the monthly notices of the Royal Astronomical Journal in 2019. The first paper takes a look at the complex ways in which objects in the outer solar system are affected by the Jovian planets, namely Jupiter, Saturn, Neptune, and Uranus, while the second paper looks at a specific family of icy bodies and how they're transformed by Jupiter into potentially deadly comets. Looking at the findings of the 2 papers, it seems the Jupiter shield theory is in serious jeopardy. Actually, I wouldn't say that it's in jeopardy, I would say that it has been laid to rest, Grazier told Gizmodo in an email. Our simulations show that Jupiter is just as likely to send comets at Earth as deflect them away, and we've seen that in the real solar system. To be clear, this was a very good thing when the Earth was young, as comets and asteroids delivered the essential ingredients required for life. Today, however, these impacts are most certainly not good, as they could trigger mass extinctions similar to the one that extinguished non-avian dinosaurs some 66 million years ago. Grazier's papers present new models that demonstrate the complex astrophysical processes required to convert distant celestial bodies into local threats. Working with collaborators from NASA's Jet Propulsion Laboratory and the University of Southern Queensland, Grazier showed how objects in the scatter disk, a ring within the Kuiper belt that contains many Neptune-approaching planetesimals, are influenced by the Jovian planets. They also show how centaurs, a group of icy bodies in orbit beyond Jupiter and Neptune, are transformed by Jupiter into potentially Earth-threatening comets, specifically a collection of objects known as Jupiter family comets. Using simulations, the researchers found that centaur objects, Jupiter family comets, and objects in the scattered disk are not dynamically distinct populations, that the orbits of objects in these families evolve under the gravitational influence of the Jovian planets, and objects can move between these 3 dynamical classifications many times over their lifetimes, said Grazier. The researchers used a jet propulsion lab tool that allowed them to simulate the positions of Jovian planets at any given point in time. The gaps between these planets were then seeded with particles, that is icy bodies, placed in random orbits. The model crunched the numbers, predicting the positions of both the planets and the particles along their orbits over long time periods. The simulation could churn out results at regular intervals, but also when an interesting event occurred that strongly influenced the trajectory of a particle. The model affirmed a long-standing hypothesis that centaurs are fed by the scattered disk and that the Jovian planets play a role in this process. More ominously, the model also showed how Jupiter family comets, JFCs, are born. This research was equal parts planetary dynamics and computer science or, arguably, data science, said Grazier. In our simulations, a large fraction of the objects that become JFCs are first grabbed by Jupiter into what are called temporary capture orbits, or TSCs, orbits that circle Jupiter a few times, then leave Jupiter, often on a very different orbit. We know that TSCs happen. The comet B/111 Helen Roman Croquette spent over 11 years in orbit around Jupiter in the 70s and 80s, and will be captured again in the 2070s. The exit geometry from these events is what determines if the object is on a JFC orbit or not. That JFCs actually exist was already known. In 1767, an object code D/1770 L1 Lexel made a close approach to Jupiter, causing it to migrate into an Earth-crossing orbit, thus becoming the first known Jupiter family comet. We've known that Jupiter converts outer solar system objects into JFCs for some time. We just haven't had a model for exactly how that process unfolds until now, said Grazier. As for Jupiter or even Saturn still acting as a shield, Grazier said that remains true, but these gas giants mostly protect Earth from objects caught between them. As for objects found in the outer solar system, that's a different story. In an email to Gizmodo, John T. Horner, a co-author of both studies, said Jupiter performs a dual role. It takes things that threaten Earth and flings them away, clearing space near our planet. So in that sense, it is something of a shield, said Horner, an astronomer at the University of Southern Queensland. On the flip side, though, it takes things that come nowhere near Earth and flings them our way, meaning it is also a threat. To find out which side is more important, to determine whether Jupiter is truly friend or foe, you need to look at the story in some detail. Interestingly, these simulations also predicted the presence of other planetary family comets. One interesting thing our work highlights is that Saturn, and to a lesser extent, Uranus and Neptune, also have their own comet families, but those are much smaller than those controlled by Jupiter, said Horner. Whilst it might seem like our work is predicting something we haven't yet seen, it's actually the case that our work is supporting and explaining what we already see. The Jupiter family comets have been known for a long time, and it has always been thought that Jupiter throws them inward and controls their orbits. Disturbingly, this remains an ongoing process. The population of centaurs is constantly being replenished by the scattered bits of debris found in the scattered disk. Consequently, JFCs are an ever-present impact threat, as the authors wrote in their 2019 paper. We already know that Earth is in the cosmic crosshairs, said Grazier. There are hundreds of near-Earth objects that are potentially hazardous. I think we now just have to pay more attention to what's happening a bit farther away in Jupiter's neighborhood. Excitingly, NASA is considering a pair of missions to study Jupiter's centaurs up close using two spacecraft, named Centaurus and Chimera. These missions, if approved, could tell us more about the origin of the solar system, but perhaps more importantly, they could tell us more about the ways in which these objects pose a threat to Earth. Please save trees and nature. Please subscribe my channel. Thank you.